All right, we're back. We're still on page 179. We're talking about parametric equations. We just talked about the unit circle as a set of parametric equations. We know a lot about the unit circle. It goes counterclockwise, takes 2 pi to trace out entirely. We know where we are at a lot of values, right? The 17 famous angles. Just a ton of information. And then we were playing around in GeoGebra. Hopefully you made your own GeoGebra sketch that you can continue to play around with. I didn't save mine. If you go to the website though, where you got the notes and then click on, in the description of the notes, I think there's a link to like some GeoGebra pages. There's one that has a unit circle explorer. There's like a bunch of things there you might want to check out. So perhaps do that. So one thing to point out that our graphs are going to have what's called an orientation, right? So clockwise, counterclockwise, it's just the direction in which you are tracing out the curve. Sometimes it's easy to do that, sometimes not easy to put it on the curve. And like, honestly, it's not going to be an issue. If it's convenient, put it on. If it's too difficult, like if the curve is self-intersecting, like how are you going to do that? So don't worry about it. But in general, the orientation is the direction you go as the parameter increases, right? So like for functions, we talk about increase and decreasing, meaning as x goes from left to right, as x gets bigger, does the y value increase or decrease? For parametric equations, we talk about like which way are you going on the curve as the parameter increases, because that's a relevant thing to know. So orientation is kind of a new idea. Let's do this. So use the table to graph the plane curve determined by the parametric equations x of t, y of t. So when t is -4, for example, we know that x will be 3, y will be 2. That's an ordered pair. So if I go to 3, 2, if I try to go to 3, 2, this is where I am when t equals -4, which, like, I don't know. So what does it mean for negative t values? There's a place in your life where you've heard this, almost certainly. Have you ever watched a rocket launch and you're listening and, you know, they're in like mission command or mission control or whatever it's called. And before the rocket launches, there's a countdown and the countdown has negative time. It's like t minus 5, t minus 4, t minus 3. When you get to 0, that's ignition. And then it'll take off and time starts counting up because everything is based on launch time. So there's negative time, that's just before launch, and then there's positive time, that's like during the mission. So because every mission starts at t equals 0, so you can like count things out like really well from there. Same kind of idea here. So t equals -4, you could think of it as like 4 seconds, 4 minutes, 4 hours before you started really paying attention. You just happened to also know that it was at 3, 2, however you want to think about it. So when t is -2, we're going to be at the point 6, 3. Maybe I should like color code this. So we were here. And then when t is equal to -2, we're going to be at the point 6, 3. So 6, 3, I guess, is kind of like here. This is like surprisingly hard to do. Plotting points, I don't know why. Pretty hard to do. So this is when t equals -2. Like, you don't really need to put the time on every single point. Sometimes it's convenient though. And also we're just starting out. So like maybe we should be annotating as much as possible. When t is 0, you're at 3, 4. So that's going to be up here. All right, so like t equals 0 might be like, you know, ignition, like you're about to lift off. Like that's when you're starting. T equals 2, we somehow managed to get ourselves over to -2, 1. So that's when t equals 2. So the weird thing is, unless you label the time, the parameter doesn't show up in your plane curve. Like it just is not really a part of it. So it determines the plane curve, but this is an XY axis, right? This is X, this is Y, there's no T. Like the only way T is gonna show up is if you put it in. So like sometimes you do. So that was this point. And then finally, we get at t equals 4, we get to 0, 0, which is maybe that's where you land, who knows. This is t equals 4. All right, so the question then becomes, like, what is it said use the table to graph the plane curve, but like, we don't really know anything, right? So I think that what most people would do, I think it's what I would do, is I would say that the curve is probably this, and then this, and then this, and then this. But there's really kind of no way to know. So actually what I did was I made a GeoGebra thing for us to look at that has like a couple of options. I did not take the time because it would have taken forever. I didn't take the time to make it actually go at the amount of time that it should take. But for example, the first path that I thought it would be is probably this. Like, why would it not be that, right? Well, maybe it's not that. Maybe instead of that, maybe it actually does this, right? Like it goes a little faster or whatever. It's like kind of like rounding the bases. I don't really like that color though. Can I change it? Why are your colors all weird? No, no. Okay. So here, it's like we started at A, we end up at B, but maybe we didn't go in a straight line. And then here, you know, you take the corner and then you got to get to D. So you're going to turn around, you overshoot it a little bit, and then you end up D. Like there's no way to know that didn't happen because all we know are 2-second intervals. 2 seconds is a ton of time, especially if you're going very fast. Another possibility, what if actually this was happening? Right? And there's, again, no way to know that this wasn't happening. So maybe there's like this extra phantom point that for some reason a thing is moving and it's passing through that point in the interim. Like, because we only know -4, -2, 0, 2, and 4. We don't know everything in between. Why are you going backwards? So it's possible that's happening. So I accomplished a lot of this by doing weird GeoGebra things. So like here, I use something called I think it's a spline. It's either a spline or a spleen. I think it's a spline because of line. I think line's involved there. The GeoGebra just does all the work. And I like sort of at some point knew what it was doing. It's like a weighted average of things, I think. I don't know. That's a very cool feature. You just give it a list of points. It does all the work. I recommend you try to play around with that. Like put some points all over the place. Here, let me show you. Because I'm all about like playing with GeoGebra, and I think I've learned not as much from GeoGebra as I've learned from other things, but I've learned a lot. So I'm just gonna put a bunch of points. I'll put 6. And then I'm gonna type spline or spleen. I think it's spline. And I'm just gonna use the first option because honestly, I don't exactly know what it's doing. You could look up the documentation, it'll tell you. And then I'm gonna put them in order, B, C, D, E, F. And I'll hit enter, right? And you can see it has made parametric equations. So the X coordinate is determined by something, the Y coordinate is determined by something else. You can move the points now and the curve is gonna change. And it's pretty wild. Like, look at this. And so you can do all kinds of things. It looks like I kind of like tied a knot or maybe made a Pringle, like I'm seeing it. I don't know if you're seeing it. Or a cowboy hat, I don't know. Definitely play around with that though. I used that to create this potential curve, which is B, and I also used it to create this potential curve, which is a little simpler. I created a slider called K, and then the point G, the point that was moving, so the point that's moving around right now, is just C of K, right? So C is a curve that I created. There's a lot going on here. But basically what I did was just, I really just did like B of K, and it put a point on there and it moves around. Anyway, you got to play around to learn, right? So key information here though, let's go back to the notes. We don't know what the graph looks like. We're kind of inferring what the graph looks like, and it probably doesn't look like what we think. And the problem is, and you're gonna run into this, especially, this is a big time calculus idea. 2-second intervals are huge. It's not enough. If we had 1-second intervals, it would be better. If we had 0.0001 second intervals, it'd be like ideal because there's just more information. So the assumption that I made was I kind of like assumed straight lines, and we don't want to do that. And it would be better if we just had more info. So we need more info to get a better graph. Now, can we put the direction on this? We can. Do we really need to? I would say on this one, we don't really need to because it's not like self-intersecting, and we put the times. If you put the times, t equals -4 to t equals -2, time has to move forward. So we have to have gone from here to here. And then -2 to 0 had to go this way. But you know what? It doesn't hurt anybody, so I'm gonna put it in. The orientation of the curve is this. Sometimes it's hard to put the orientation of the curve on, especially when things intersect themselves, which they do a surprising amount. But if we had more info, right? Like, say we had, say delta t is 0.001. That's way better. We'd have we'd have like 8,000 points, but it'd be better because we would know like the fine details of the graph and then have a better idea. Anyway, the point is, well, there's so many points. One of the many points is that we can take a table and turn it into what we think the graph kind of looks like. We can't be super sure, but we can be pretty sure. Well, we definitely know its position at these points. That's actually all we really know. So that's kind of weird. We don't even know. It could double back and hit a point again, I guess, right? It could go like this. And like, there's nothing wrong with that as long as it does it in the time interval that it needs to do it in. So I'm going to stop this one here. Again, introduction to parametrics. Play around with GeoGebra, in particular the curve command. And then those splines or spleens or whatever are just really cool. They're a cool way to get like weird curves going for you, if that's what you're kind of trying to play around with. I will be back in the next video and we're going to keep going. So I will see you there.